So this is a video lesson on dividing by unit fractions specifically. And this is part one of a two-part video lesson on what it means to divide by fractions. With this first video going into what it is to divide by what are called unit fractions, and the second video going into what it means to divide by fractions that are not necessarily unit fractions, or just any fraction in general. But this lesson sort of sets up the background for dividing by unit fractions, and then is referred to in the second video on dividing by non-unit fractions. So before we can go into anything about dividing by fractions, we need to make sure we review and understand what is division. Because understanding specifically what division is absolutely critical for understanding why dividing fractions is the way it is, and particularly why dividing unit fractions is the way it is. So take a second, pause the video if you like, and think of a few examples of what is division. Maybe you can think of an example in life where you would use division, or maybe you can think of examples of what division is specifically. But if you're having trouble thinking of that, originally think, what does the expression 12 divided by 4 actually represent? What concepts are we using? What are we actually doing when we divide 12 by 4? Well, let's take a look at a concrete and visual example when it comes to dividing 12 divided by 4. Well, one way to look at it is we have 12 apples. We're going to use the apples here at the left to demonstrate this. And if we're dividing it by 4, we want to divide this one into 4 groups. We have 12 apples. 4 friends are going to share them. We want to be as fair as possible. How many equal groups can we create that can be shared evenly amongst 4 friends? Well, we've already separated this out into 1, 2, 3, and 4 rows, so we can count. 1 group, 2 groups, 3 groups, 4 groups. So we split the apples into 4 different groups. So 12 apples divided into 4 different groups equals 3 apples per group. And so that's the first thing we think about, is multiplication is splitting things into equal groups. The first number is split into however many equal groups are represented by the second number. Now this is particularly helpful when it comes to dividing integers. When it divides into fractions, it's not entirely clear what this is. However, we have a second way that we can look at fractions. It's a little bit more clear, that we can look at division that is a little bit more clear when we're dividing by fractions. And that is 12 divided by 4. My question now is, what do I need to multiply 4 by to make 12? Or, how many groups of 4 can I make? Well, if we look at this, our groups now are separated vertically. The group of 4 in the left-hand column, the group of 4 in the right-hand column, or the center column, group of 4 in the left-hand column. So 1, 2, 3 groups of 4. How many times does 4 go evenly into 12? Or if it doesn't go evenly, what fraction do we need to multiply 4 by to make up that difference? So how many 4s do I need to make 12? And that is really what we're getting at when we're dividing by unit fractions. And it's a way where you can conceptualize what it actually means. But first, let's go back and understand, what is a unit fraction? Well, a unit fraction is a fraction like 1/21st, where the numerator is 1. 1 is also known sometimes as a unit being another word to say 1. So any fraction that has 1 as a numerator, 1/2, 1/5, 1/32, 1,351st is a unit fraction. The critical thing is that the numerator must be 1. So now when we're dividing by unit fractions, we understand what that means. So let's take an example of, I have a watermelon. I want to split this watermelon into fractions of a watermelon so I can give it out to people. I'm thinking I want to split the watermelon into fourths. How many fourths of a watermelon do I need to make one whole watermelon? I only have one whole watermelon, and I need to split it into fourths. Well, that, if we write it down mathematically, is one watermelon divided into fourths. Well, if we're familiar with fractions and what fractions represent, then we know 1 as the unit is the same as 4 fourths. So when we think about division as how many fourths do I need to complete a 1, 1 divided by a fourth has got to be 4. So we're looking at 1 divided by 1/4 is equal to 1 times 4, because there are 4 fourths in 1. Let's look at a different example. We're now looking at a mile stretch of road. From the left-hand side here to the right-hand side here, our road is 1 mile long. And now we're looking, you decide to run a mile in 1/5 mile segments. So you run a fifth of a mile, then you stop for a break. Then you run a fifth of a mile and you stop for a break. And you run a fifth of a mile and you stop for a break. And so on and so on. And our question then is, how many times do you need to run 1/5 of a mile to make it into an actual mile? Well, we have 1/5, 2/5, 3/5, 4/5, 5/5. 1 is the same as 5/5. So that means if we're running 1/5 of a mile at a time, we need 5 of those fifths to make it to 1 mile. In other words, 1 divided by 1/5 has got to be 5, because it takes 5/5 to make 1. Now, what if we upped our example to representing 4 miles? You've decided to run 4 miles now in 1/5 mile segments. How many times do you need to run a fifth of a mile? Well, the first question that we need to think of goes back to what we said before. In 1 mile, how many fifths are there? Well, 1 mile represents 5/5. In a second mile, there are 5 more fifths. In a third mile, there are 5 more fifths. And so on, until we get to our final mile. 5 more fifths. And now, just by counting, we can add up 5 plus 5 plus 5 plus 5 is equal to 20. Alternatively, we have 5/5 of a mile times 4 miles means we have to run a fifth of a mile 20 times to make it the full 4 miles. That is because when we have 4 miles, we can split it up into 4 ones. And as we said before, each of those ones represents 5/5. So if we think of that, each of those ones represents 5/5, and we have 4 miles that we need to be worried about, for each one we have 5/5. So for 4 miles, we have 4 times 5/5, because 4 miles times 5/5 per mile is equal to 20/5 of a mile. Alternatively, 4 divided by 1/5 is the same as 4 times 5/5, just like 1 divided by 1/5 is the same as 1 times 5. So what does this leave us with? Think about 1 for a second. And now we're going to get out of the fourths and the fifths, but think about 1. If we have halves, we need 2 halves to make a 1. If we have thirds, we need 3/3 to make a 1. If we have fourths, we need 4/4 to make a 1. And generally, whatever our denominator is, which I'll represent here with the variable n, we need that many of them to make 1, which leads us eventually to our rule. If you're going to divide by a unit fraction, you multiply that first number by the denominator of the unit fraction. Because for whatever number we have, each one of those numbers represents 2 halves, 3/3, 4/4, 5/5, etc., 17/17 as we go. So if we're looking at the example in numbers, if we have 5, and we're going to find out how many sevenths it takes to make 5, well, each one requires 7 sevenths. So if we have 5, that means we have 5 ones times 7 sevenths per 1 is 35. And if we look at it in algebra, where we are now using variables to represent all those numbers that could change, a number n divided by the unit fraction 1 over a is the same as n times a, because for each one, it takes a eighths to make 1. So if there are n of them, it takes n times a. And that is true whether or not our n is a whole number or our n is a fraction. So let's take an example of that involves a fraction and see what we can do with it before I let you off to do an example on your own. We have 3/4 divided by 1/2. We want to find out how many halves there are in 3/4. So what do we need to multiply 1/2 by in order to make 3/4? Well, we have our first number, which is 3/4. We want to find out how many halves there are in 3/4. Well, in every one, there is 2 halves. So in 3/4, there are 2 halves per one times the 3/4. Multiply that together, you get 6/4, or 3 halves. Now, the analogy gets a little bit more difficult when you're talking about dividing fractions by fractions, but the same logic holds true. 3/4 is just 3/4 of a 1. So it takes 3/4 of the 2 halves to make 3/4. And in that case, we get 3 halves, or 6/4 as our answer. So again, looking back at the rule before we practice, to divide by a unit fraction, you just multiply the number, that first number, by the denominator of the unit fraction. So take a second, look at these 4 examples. 1, 2, 3, and 4. And see how you do with dividing by unit fractions. Go ahead and pause the video, come back when you're ready. So for our example number 1, we keep the first number the same, which is 5/7, and now we multiply by the denominator of the second fraction, which is 14. And remember, this works because it's a unit fraction. Now we can multiply 5 by 14 over 7, but we know that in multiplication, we can cancel some things before we actually multiply through. 14 divided by 7 is 2. Or, because this is all going to end up as one fraction, because that is how we multiply fractions together, 14 and 7 are going to end up as numerator and denominator, or at least as part of numerator and denominator. So we can divide that 7 out before we even multiply. 5 times 2 is 10. And we have no denominator because it's 1 times 1, and that is our answer. 8/15 divided by 1/5 for our second example. Again, 8/15 stays the same. 1/5 becomes a multiply by 5. In the end, we get 8 times 5, which is 40. Over 15, divide each by 5, and you get 8/3 as your answer there. 2 1/5 divided by 1/20. Now, we keep the first number the same, keep it 2 1/5, and multiply it by 20. But we know that when we multiply mixed numbers, we have to change mixed numbers to improper fractions. So this becomes 11/5 times 20. We can't just multiply a mixed number by a number. We need to change it to an improper fraction to make sure that we're taking into account everything we have. 20 times 11 is 220 divided by 5. 220 divided by 5 is 44. And finally, 1 2/9 divided by 1/21. We know we need to change the fraction into the mixed number and into proper fraction. So that is 11/9 times 21. I'm going to go ahead and cancel a 3 from the 21, make that a 7, and a 3 from the 9, because it's from numerator and denominator, make that a 3, and we eventually get 77/3. If you want to change this into a mixed number, that is 25 2/3. So one more time, to divide by a unit fraction, you just multiply by the denominator of that unit fraction, for the reason that for every 1, there are 7/7, 3/3, 2 halves, 9/9. Whatever the denominator is, it takes that many of that fraction to make 1. So whatever that first number is, we multiply it by the number of 14ths, for example, that it takes to make 1, the number of 20ths it takes to make 1, the number of fifths it takes to make 1, and we get the number of that fraction, the number of that unit fraction that it takes to make that number.